Hi, it's nice to see such a full room. Thanks a lot for having me, and thanks to Scala-centric for inviting me here. I'm very glad to be here with you today to speak a little bit about Spark, about Scala, about the Spark notebook. The approach I'm going to take is that I'm going to use a small example of what I think us Scala engineers can contribute in the big data systems in order to enrich the, let's say, both you personally and professionally, and also to enrich the systems you're working on. So I'm going to do a little bit of data engineering with you today. The first thing, let's get this through. So this is me. You can ping me on Twitter at MaasG. The shameless plug, I'm co-author of Learning Spark Streaming. It's not out yet, will be out there in the summer, so please go and enjoy it. And I've been working with Cassandra and Spark and Scala for a while now, for about several years. Currently, I work at Kensu.io. We are a startup. We work on the data science governance, and this was born actually from the users of notebooks in companies and enterprises. They wanted to get hold of what data scientists are doing. They have a lot of freedom of using data, and then how let's say the layer above can get control of can get a bit of governance on the data that is manipulated, the data that has privacy concerns. And we started working on this project called Analyse that is tracking the use of data. So I see it as a context system. It gathers contextual information on how processes run in the enterprise. And I'll give you a second of a demonstration. So it builds up knowledge graphs of execution context. You have data sources, and then you can dig down and see schema information, and finally put all the dots together within enterprise and see full image. All right, with this small break, message from my sponsor, let's keep on going on the presentation of the theme of the day. Yeah, let's go here. I think Spark doesn't need an introduction, so I'm just keeping this placeholder here to tell you that it's becoming like the de facto standard for data analytics and data pipelines, and it's building and enriching the open source space for let's say the whole data engineering part that is growing very fast today. So we have like the streams that can come from Kafka. You have databases all supported, like Cassandra, like MySQL, a lot of connectors on the data side, and then several modules of Spark modules on the top that enrich the experience of the users. So the most recent part has been the great progress on the Catalyst optimizer for queries, and the implementation of a DSL, a domain-specific language for data frames and data sets that got rid partially of all that low-level RDD functionality that was early on in Spark. I don't know how many are you familiar with Spark, because I'm taking it as for granted. I'm very sorry for those of you who are not familiar, but I'm going to show you a bit of what Spark can do. And what you can do with Spark can be facilitated by the Spark Notebook. The Spark Notebook delivers you an interactive environment. And I'm going to jump right in with the interface of a Spark Notebook. It's an open source project. It's available on GitHub. I will show you the links later on. And what it's doing is combining actually Spark and Scala. So it's very focused. So you have like the three main notebooks out there. You have Zeppelin that has a lot of modules and plugs into a lot of different systems. You have Jupyter that was born from Python, and you have the Spark Notebook that was born from the Scala Notebook and combines Spark and Scala, and it's very Scala-centric. So one thing that we offer there is a Spark session here. So all the configuration is already preloaded in the notebook. If you have a cluster, you can connect to the cluster immediately and actually drive the whole cluster. You can have 100 machines behind you, and you are just sitting on your browser typing certain commands. Let's go through and below, let's get some cells. It's cell-based, so the interaction here is you can type any expression in a Scala, so you can have typical 2, 3, whatever, and it will interpret. It has a REPL behind, but it has the Spark REPL behind. So you can do fancy stuff, not only to have the simple expressions, but you can load a full data set and explore that data set. So we implement some visualizations for data sets and data frames, and those are kind of built in for many of the supported types. So it's all type driven, and if we want to see what the airport data set has, so it has some data is one of these data sets. Oh, sorry, you want it bigger. Let me try to enlarge it a little bit. Yeah, is it better like that? All right. And I prepared this already because I'm terrible at typing with people in front of me. So I have this demonstration here that contains exactly where we are right now. We have the airport information, and we can start then doing some manipulations on that export information. So one of the things is, this was taking a bit longer. I'm going just to reduce it. I am going to just use the DSL, the data frames DSL, to do select on this table. This is a JSON file. So you see here we are kind of doing SQL on JSON. Very easily. So now we just have a data set that has the latitude and the longitude information, and we can see that data set displayed on a chart, on an interactive chart. So we see there we are dealing with the airport information of the US, and we have like per city, we have a distribution of it's very hard to manipulate like that, but don't worry. Okay, so you get the point. So we have the information there of about every entry point there. So the Spark notebook is combining the power of Spark with the facility and easy of use of the Scala's APIs for collections and for manipulating data in general to enable you to explore data in a very generic way, but also providing you the tools to gain insights on the data. So we have a bunch of display charts possibilities built in the notebook. You don't have to like export your data set when you worked on it in Scala and you did your export or your cleanup and then put it in another tool to visualize it. You can directly interact with your data from the notebook. In this case, I'm going to group the count of airports per state, and I'm going to have a look at how the data looks like, and I'm going to do a bar chart of it. So here we see that we have, I always forget what AKA is, the thing in the north. Alaska, exactly. We have Alaska and we have Texas, the first two, and then you see the distribution of the data afterwards. Very easy. You take data sets. You can work with very large data sets. So only take care that you are not loading all the data back to the notebook. This is all based on a reactive interaction from the notebook with the backend. We have a kernel running Spark behind the scenes here that is doing all the crunching for you and only replying back with the answer. But if you will ask like 20 million data points here, then certainly your browser is going to bark. What I wanted to share with you today is about, and I'm looking at the clock, is about data engineering. What is data engineering? Data engineering is this field where you want to take the results of some investigation like we just did. We just looked into what the data looks like, and then building up infrastructure that lets you process the data. So data engineering is capturing the data, is collecting the data, is putting filters in place or processes in place to enable the data citizens of your companies to manipulate the data in an easier way. One of the parts of areas of Spark. So Spark has evolved a lot the late time, and it has included all these SQL-like languages that enables a lot of people to play with it. But us Scala developers are placed in a prime position within the Spark community because Spark is a native language, Scala is a native language of Spark. And there are certain places, I'm not saying everywhere, but there are certain places where the Scala plays a key role. I'm going to show you one of those places today. And I'm going to go really fast through it. Sorry, it's very limited in time. Normally, I would go a little bit more calmly paced through this content because it's a little bit complex to get through the first time. What I'm going to do is I'm going to do some language classification. And I was inspired by a National Geographic program at some point that were saying, no, the Mayas, the Aztecs, sorry, they had a very complex way of communicating, and all their textual communication, they couldn't figure out how it was looking like because they couldn't figure out an alphabet behind it. And it kept me kind of curious, and I started looking into that. And one of the most trivial ways to compare into languages and trying to see if a phrase, if one language or the other, is getting the frequency of the letters and comparing those. But you see, it's kind of not very accurate. This is Spanish versus English, and you see that you cannot exploit that much of a difference between the two. So having let's say a discriminator, having a model based in that naive approach will be very hard. And then I came across this paper from Kaffner and Trenkel, where they are working with n-grams. N-grams are fragments, are little pieces of a string. So if you consider your text, the Telegraph have a lot of text available, and you start breaking it down instead of words like the natural way we would do, where you start going to break it down in little nibbles, little pieces of a determined length. So you will start with size 1 that will give you all the letters, and then size 2 will give you all the pairs of the letters that are together, size 3 that will give you the 3 letters that are together, and so on you go. And it turns out that you can get up to a 98% of accuracy using this process. And not only for language classification, but you can also do text classification. You can rather understand what topics are being dealt with in the text with this very simple approach. So all you need to do is to chop things in pieces and then do some very limited statistical manipulations in it. The cool thing I want to show you today is how to turn this into a language classifier in Spark. Why? Because this is the kind of stuff that you can play, let's say, a key role. You can go into the Spark API and add functionality to it. And you can add, in this case, we're going to implement a model that can be used to classify large amounts of data. So instead of going through it into an iterative way, what we're going to do is to have an ML classifier, machine learning classifier. We're going to build the whole interface that this classifier needs to comply to using a model that we have trained by hand. Let's say, kind of speaking. I cannot go through this line by line, so I will go through this paragraph by paragraph. So the first thing that we're going to do is we're going to combine Spark and Scala. And this combination will be done here. I'm going to define some functions that are able to chop my data the way I want. And that way is by first replacing all characters that they cannot understand very well, and then I'm going to start creating growing slices of small naps, small pieces of text, and in that way I'm going to take a small text and really transform it into a very large collection of pieces of characters. This is just a function here, so you see it just takes a string and delivers you a sequence of strings. And there are some built-in tests in my notebook. This is like your way of ensuring that the code that you're writing is correct. So notebook is very interactive, but sometimes you want to have a sanity check. And that sanity check you can implement with simple requires or asserts. Then I am supporting 6 languages here. You see Spanish, English, Italian, German, French, and Dutch. And every of those data sets has been already preloaded here. So I just got a batch of text on those languages. And I'm going to take every body of text. So I have many texts in Spanish, in English, in German, in French. The trick I did was to download a lot of European Commission regulations and laws that are translated exactly in all those languages. So I have a very solid data set or source data to work with. Now, I am going to combine here, and this is tricky. When you talk to recent, let's say, newbies in the Spark community, they will tell you that data frames and data sets are everything, and you shouldn't look back. And for me, you need the right tool for the right job. The right job here is to deal with the level of granularity of collections, and the collections API of Spark is a distributed collection. It's a natural distributed collection. Lets you combine it with the classical ways you know of working with collection in Scala, and then you can. So here I'm going to work on the data sets. I'm going to load them, and I'm going to apply the function that I already know that I wrote in Scala right on my data. So if I had a cluster here available, it will be just spread out over the cluster and run rather fast. This is just some sanity check, so it's just to see what I got as results. You see that some words are being split and the size is growing, so we will go from 1 to 5. I did my cut on an n-gram of 5 characters, because otherwise you will really grow your data set and make it really large. And then I'm going to build up a profile. This is kind of boring if you would do one by one, but it's just to show you how that looks like. This is an n-gram distribution frequency distribution, sorry, and this is, I think, for English, and I have the one for Spanish right below. Before, in the slides, I show you the two distributions that were like very similar, but now we can see how an n-gram distribution looks like. And let me see if I can get this without a mouse. It's rather annoying. But there are very curious things. So you will see like common prepositions in English, like D is very used, like the E is one of the most used letters in the English alphabet. And then we can compare with Spanish, and then this is very curious because D, it translates to D in Spanish and are rather in the same place in the two distributions. So you are seeing already that this method of language classification is a lot more powerful than the naive approach. Also, we see that E and A are also there in the forefront of the alphabet usage. Then this is, you can look at it in detail. I will show you the GitHub repository right afterwards. This is the gist of the whole thing. Here we are turning those data sets that we just crunched and turned into pre-digested models for language classification. And we are going to turn it into a classifier. This is let me see. This is a transformer in Spark that lets you take a data frame and transform it into another data frame. You have to implement the interface. It's a number of methods that you need to comply to. And what you see here is I'm actually reusing some of the code that I had already in the notebook and putting it all together in a function. Actually, what I want to extract from my notebook and from my session today is only that. All the other was just helping me in understanding the problem and exploring the data to see that I'm actually walking in the good direction. Then at the end, what we do is, okay, I won't go into the accuracy testing, but this is the user code. This is your end user. So you are delivering this to some other people that are just only interested in classifying bodies of text. They are not interested into doing crunching on Spark. They are not interested into going to creating models by hand in Scala. They just need to say, okay, this is my language classifier, and I now get some test data set that I load using the data frames API, and I transform it. So my test data set, it looks like this. There are expressions, so there are phrases in the original data set with the language, so I know what language they are, just to test that things are going correctly. And after the transformation, what's going to happen, my transformer is going to add a new column there with the classification, and we see there that we are doing pretty well. So the predicted language, it's very accurate with the actual language of that text. So you can apply it with some degree of confidence on your data. All right, this is just one example of what you can do with the power of Scala applied to Spark, and then dealing with data, and let's say growing in the data engineering path. Here's two last slides. We went through this. The Spark Notebook, the tool that you saw, we are the maintainers of it. We are currently adding more and more features to that. We added Git integration very recently, and now we have a project generation. A project generation is very neat. Once you're done with all your process, what you do is you go here, you say generate SBT, and this SBT will give you some options, and it will start generating a full SBT project. So it will generate the configuration, the SBT build, so the SBT file, and I will translate all your notebook code into code, and all the comments will be added like Scala comments like you would expect. It will be a nice thing to have. And then I'm going to close down already with the resources. There are many mixes of it, sparknotebook.io. This is the GitHub repository if you want to contribute or download the source code. And those are the notebooks of the day. And that's what I had for you today.